Um, Ladies and gentlemen of the LENR research community, my compliments for your accomplishment in about 35 years of research. You have accomplished a complete paradigm change. We are entering a new scientific revolution, as I see it, and this will change everything in science, in politics, and in also entrepreneurial action. Everything will change. A paradigm shift is happening. This is what I'm going to talk about. So that's how it works. Oh. Who am I? I'm a clinical psychologist. I graduated in 1978, had a master's, and my main concern is mental health strategy. So I'm a bit of a strange duck in this experimental pond. And but my interest in the matter was caught by the paradigmatic conflict of LENR, relating to the outside world of science and also common understanding. There was a conflict that rose, and I want to put an end to this conflict. I'm writing a book about it, and I want to communicate it with you, what these conclusions are. The cup of paradigmatic conflict is as follows. We had electrochemistry and nuclear physics that ran into opposition. And this is how it looks like. Nuclear physics says extra heat is needed as a cause of fusion. Electrochemistry says extra heat is there as a consequence of a nuclear process. The skeptics at the nuclear physics side say, okay, there's insufficient fusion products and radiation to justify the claim of fusion. It was called cold fusion in the beginning, but we had to give that up. But the defense was, okay, there's a correlation of heat with the fusion products found. This is what we arrived at. The critics said, okay, this is not sufficient. This correlation cannot imply a causation. So was fusion but a side effect? We've been talking about it this week. The result, in fact, was worldwide a confusion, a paradigmatic confusion. How can this anomalous LENR heat and fusion exist? We are dealing with an anomaly, which is a good thing for science. The paradigmatic truth about fusion is that stellar physics says, gravity is the cause of fusion. We compress hydrogen, we get fusion. Cosmology says expansion is the cause of fusion. We have a Big Bang, and as a consequence thereof, we have nuclear synthesis and fusion affects everything. If you combine these two and you don't look at the cup of poison of our conflict, but at the faces, this is paradigmatic psychology, and you see the truth, then you arrive at the simple conclusion that nuclear fusion is there from a dynamic, universal, hydrostatic equilibrium, as it is called, between gravity and expansion. So, with fusion thus known, is LENR understood? No, not quite. The gap remains. We are still a small community, and the rest doesn't really understand what's going on. We can bridge this gap, this paradigmatic gap, by explaining why excess energy is produced. We need to build a bridge. Oh, that went wrong. There it is. Oh.
We get it.
Yeah, okay. I have to go back. Okay, okay. A certain dogma must fall of nuclear physics for us to accommodate within science. The alternative for us is that if fusion is but a minor side effect, if we take the critics seriously, if fusion is just a minor side effect, then we have to count with an influx of energy from outside the system. Fleischmann from the beginning together with many other prominent LENR researchers, concluded that, well, there must be we are dealing with something new, a third process of nuclear energy generation. It implies, anyhow, a paradigm shift involving more than just the Fleischmann and Pons effect. So, oh, there he is again. Oh, now he stays. Okay, fine. The purpose of this talk is to share the results of my LENR study, of course, because I wouldn't go ahead and defend LENR without your knowing it. Secondly, it is to introduce a few other research subjects I've been missing, even though the previous speaker mentioned things relevant. I will further elaborate on. Thirdly, we have to, in fact, tear down this wall of ignorance and denial about LENR with a most likely non-fusion explanation. So there is fusion, but we need to communicate also a non-fusion explanation. So we have to prove that LENR is no bad science. We are communicating with the rest. So we have to discuss three major physics problems. They all concern the subject of time. For these problems, LENR offers a solution for which we have an alternative model to understand what's going on, because that's a great challenge. So problem number one in physics generally is time as a force. Is time a force? Time is a dimension. It's difficult to understand. We're talking about 5 dimensions just the other minute. And there's time as a field with particles. We all know this. But LENR has consequences for these domains. We have to see the big picture, like blind man touching an elephant, which is called LENR. We're all speaking different languages, and we have to arrive at a unitary vision. So experimentally, we focused on practical applications. Theoretically, we focus on quantum mechanisms, but now we have, for a more holistic view of LENR, to communicate with the rest, we have to branch out towards cosmology, theoretical physics, and particle physics. It's no small affair for anyone, but you can break it down to these basic concerns of the basic forces of nature, the dimensions of nature, and the standard model. So, thus we will first discuss problem number one, the forces of nature. Everybody knows the usual four of gravity, electromagnetic force, the strong nuclear force, and the weak nuclear force. And it is just an enumeration of force domains, though. For LENR harnessing these forces, we need, in fact, a grand unified theory. And this is the problem we have at the microcosmic level. And the microcosmic level, we have two angles that do not quite satisfy each other. There's no gravity at the microcosmic level, and the microcosmic level, there is a lot of it. So that is the problem. The solution number one to problem number one is handed to us in the form of forces of nature's cohering. That was a suggestion of Stephen Hawking. He mentioned arrows of time, 3 arrows of time, a psychological one, a cosmological one, and a thermodynamical arrow of time. These 3 arrows point all in the same direction. But now we arrive at a LENR model in which we adapt this 3-arrow concept into a vector system of 1, the force of gravity pointing down, 2, the force of the expansion of the universe, expansion force of the universe we know since 1998 about, and the circular arrow, the electromagnetic force. So this is a model in which we now unite the strong nuclear force with gravity, and the weak nuclear force with the universal expansion force, in such a sense that strong turns into weak and weak turns into strong at the atomic level, so that the atom more or less functions like a force switch. Weak gravity becomes the strong nuclear force, and the other way around. From this coherence, we might be converting with LENRs. So, That was solution number 1. Physics problem number 2, the dimensions of nature. We have the usual Cartesian 3 dimensions. Everybody knows this, that's not that complicated. But Hermann Minkowski said, oh, we have a 4th one. And he said it's time, and it raised some confusion, because how to imagine time as another dimension, it is difficult to understand. So how to arrive at a proper model for such a thing? He spoke about space-time, which implies the 3 dimensions in unity with the concept of time, space-time. But there was no general consensus again. Again, we have this cup of conflict in which general relativity opposes quantum theory, who cannot acknowledge really time as a dimension, but says, okay, time is a separate entity. So that's the problem number 2. Then we arrive at solution number 2, and that can be considered the energetic 5D space interaction. Like the previous speaker explained in technical detail, I'll try to understand it as a normal person. Sorry. But we have to consider the concept of space. How does it work, really? Well, in reality, we have 2 types of space. We have an inner space, physical space, and we have an outer space, universal space, which you can also call material, because there's neutrinos in it. Inner space is defined by electrons. So that is the material department of space. It is opposed by the energetic department of space, to which we have space-time, time with the capital T, which comprises inner and outer space, and in opposition leads to what we can call gravity, those 2 arrows pointing that way. And we have an origin of this energetic empty space called de Sitter space. That was the first time I heard about it this week from you. Very nice. But we have now four types of space. In fact, this is how we enter this 5th dimensional notion of reality. Because we have 3 dimensions in the upper department, 1 dimension with space-time extra, and there's number 5, that's point space, the original space. So normally we speak of the energy in that empty space. We call it dark energy, vacuum energy, 0-point energy, and time energy. For LENR, I would like to suggest that we speak of expansion energy. We convert, maybe, possibly, expansion energy. So that was solution number 2. But there is a history to this 5D cosmological model. Collis and Klein introduced in 1921. In 1989, Fleischmann and Pons effect said, okay, we have energy. We're not sure where it is from, but maybe we connect the dots. And in 1998, we had this shocking discovery, like Witten says. You also mentioned Witten. And it was a shock, because then we realized there's a universal expansion force that might be driving us in our experiments. And in 2012, the year Fleischmann died, there was the Higgs field proven as an energetic quantum field of space. So now things are coming together in this mind, so that we now, 2024, have paradigmatic clarity, if you think about this, for condensed matter nuclear science, in the sense of having a coherent theory of triple space, from which we have LENR, with this 5th dimension as an energy source. But this 2-dimensional schematic does not satisfy. On top it says cosmological model of space. So in fact, we need a 5D model to understand this properly as normal people. This is the cosmological model. Here we see the Big Bang at the beginning, and that is our 5th dimension. It is positioned in the past, but now just remember it as the 5th dimension. Down the funnel here, we have the movement in time which is the fourth dimension, and it ends up in our three-dimensional familiar construct of space and matter, our material space concept. So now we have a picture in our mind to be able to understand it. But, there's a but, there's always a but. This, we have to position the starting point of this fifth dimension. We cannot put in the past when we want to have it conserved for LENR as an energy source in the present. So we need a different model to keep in mind what's happening in our LENR experiments where, as a source of our energy. So in the middle of these two cubes, we have our fifth dimension, the green cube expanding with the force of expansion towards the yellow cube constitutes the time factor, the fourth dimension, and then you have the three dimensions of our material reality in which the expansion force of the universe is opposed by the gravity, arrows of red. So it makes sense. Now we see the coherence of forces and dimensions. So we're progressing now, but there's always a but. There's the other but. There's a constant called lambda. There's the constant presence of lambda. Now we have a constant presence, not in the past anymore. We have a constant presence of lambda. And, well, it was a discussion. Here we have de Sitter, also mentioned by Scott. And there was a lively discussion between Einstein and de Sitter about lambda. Einstein first introduced lambda as the factor to prevent his universe from collapsing. Lambda was needed. But when Hubble in 1929 discovered that there is an expansion of the universe, he went to discussion with de Sitter, a Dutch astronomer. So I'm Dutch, so this Dutch astronomer. And they concluded that this lambda should be abolished. And they abolished it, and we were rid of the damn thing. But in 1998, we had to reintroduce it again because of this shocking discovery of the expansion force of the universe. This accelerated expansion of the universe. So this led to this cartoon in the newspapers back then, where de Sitter, as you see here, is modeled like lambda blowing up the universe with empty space, so that we have a curved 3D material space. So now things start to add up. The preliminary conclusion now is that the universe in some 5D expands with acceleration and therefore offers an energy force of time, of space-time, space-time, we, according to the triple space theory CTTS, can convert in LENRs. So, next problem. There's one more problem to go before we are done with the basics. Problem 3, the standard model of elementary particles. After all these accelerator experiments, we ended up with lots of particles, a particle zoo. They are composite particles, non-composite particles. They constitute overlapping categories that create confusion. Normally, for normal psychology of people, they say, oh, that's too complicated. These overlapping categories, all these exotic names, we cannot follow it, and it creates aversion. It's not good for science to have common people saying, no, that's too complicated, we don't want it. So there's another problem with it. How does it relate to space-time? Because quantum physics and relativity, how does it relate to space-time? The solution for this problem is we do not mention composite particles for the standard model, which is a common practice, but now we will also use functional names for the purpose of clarity. Solution number 3. We have a full standard model of elementary particles consisting neatly of 2 axes of symmetry. We like symmetry in physics. So the violet department is the big nuclear particles. No exotic names anymore, big nuclear particles. The green department is the space particles, inner material space, outer non-material, or well, also material space, but neutrino space, electrons, neutrinos, quarks, usually called. That's the left side, the left, and in symmetry to the right, we have our connecting particles, which we categorize in 2 departments, binding and energizing ones. This still looks a bit complicated, so we can simplify it by removing the generations of extra energy. So we end up with 4 basic particles, 2 nuclear ones, 2 spatial ones, and the connecting particles. Now, a good observer, as you all know, says we don't have 20 particles in our standard model. We see here the graviton, the O boson, and the I boson. Well, my previous speaker, he mentioned the graviton, and I think it's real to consider it because we have a family of Higgsickles, as Steven Weinberg called it, and Wilczek, the guy who got the Nobel Prize for the big nuclear particle energy containment, he calls it these days actions. So this is a nice title for those particles, action particles, you know. It's our action. The idea is that we with LENR have 3 extra bosons in the standard model. That's why we call it a full standard model. And these 3 particles are responsible for what's happening in our negotiating with the quantum field of space, offering us this energy foundation. So the mission of LENR concerning this is to arrive at the full knowledge and application of the energizing mediation process of these elementary particles we have added to the standard model for full commitment, so to speak. Well, now we're almost done. The convergence of LENR theory is the consequence that we need to communicate with the rest of the world for what we are doing. So, in sum, what we are doing is we have scalar waves of space energy, scalar pressure waves of space energy called solitons, also mentioned by the previous speaker, which accelerate at a microcosmic level with fractal patterns the way you see it upright above here. These are patterns and patterns and patterns. It gives an acceleration at the atomic level. There they add up to energies for quasi-particle, subatomic, nuclear active structural vibrations we call phonons. Also mentioned before. You see it upper left here. This is the phonon dynamics of the lattice. And that may happen if there's a suitable nuclear active environment of, for instance, hydrogenated nanometal compounds, but there was also a speaker saying, well, we don't necessarily need those, but this is an example of a suitable nuclear active environment. And that may happen given the so-called McHuber formula we see in the literature of our history. Flux, current density, and hydrogen concentration are needed to arrive at a proper hydrogen metal energy production in layers of metal, for instance, like we know from the Japanese Iwamura and I will finish it. So the conclusion is we have quasi-particle QP vibrations converting space energy into excess energy, leading to nuclear reaction symptoms, and, cream on top, we have observable fractal patterns and LENR in living organisms, as Vysotsky says and Jean-Paul. So, now the conclusions are, we have the time as the cause paradigm. We have seen this in 3 departments of physics problems, which lead to a notion of space-time, or time capital T, consisting of 3 types of space, fundamental to a coherent theory of triple space, which explains the anomalies we have of excess energy LENR effects in organisms and solitons and fractal patterns, and that underscores the interconnectedness of the macrocosmic and microcosmic realm. So now our story is complete. It shows the transformative capacity of our LENR research. I thank you for your attention.
I am really sorry, but you know, we are so late. But I would invite everybody interested in your very interesting speech to contact you directly, otherwise.
Okay.
we will never do. Bob, sorry, thank you again.
Okay. This was my mentor in the Netherlands. Normally you didn't hear so much about the Netherlands, but he inspired me towards this presentation. So in honor of him.